comparative analysis of traditional education practices and problem-based learning in science, technology, engineering, and mathematics classrooms by Jeff Davis. For many reasons, education has become a flowing river with surprises at every twist and turn. An emerging rapid that school systems are facing in the implementation of problem-based learning, also known as PBL, and the docking of traditional practices. Problem-based learning, modern educational faults, and science, technology, engineering, and mathematics, otherwise known as STEM, is an educational evolution. However, PBL and STEM association runs deeper than that. Due to the watering down of modern teaching techniques, it is hard to determine whether or not education is educational anymore. There have been a large amount of educational tools introduced over the years. Teachers are finding it hard to determine where to begin. Whether it is Marzano's high reliability school system, improvement required campuses, ed camps, teach like a pirate, Kahoots, or Chromebooks, one thing is obvious. Teachers are spending the majority of their time making sure they meet the requirements of educational tools that they aren't doing a whole lot of teaching. Google has replaced traditional classrooms, and the ability to recognize an issue, consider the solution, and discover an answer has all but disappeared. It would seem that classroom has turned away from scaffolding techniques, positive reinforcements, and differentiation to a copy and paste society, relying upon students' ability to control plus C, control plus V. There is no longer a transfer of knowledge occurring from one generation to another, but rather continuous plagiarism at all levels of education. By implementing a PBL-driven curriculum within the school system, educational success that is encouraging of technology and science within every classroom is achievable. B.J. Colbert's research supported that the thought that education and long-term knowledge retention increased in PBL courses where students encounter problems that require critical analysis, in-depth research, and solution developments. The amount of student success began to steadily decline over the years until PBL was adopted. Upon successful implementation of the PBL program, student success rates continue to rise. With success, there are also naysayers that will call something a fluke and try to dissolve any true validity behind something that contradicts anything that education holds dear: content-based assessment and state testing. In Alan Donham and Bernhardt's problem-based learning, students consistently outperformed their PBL counterparts on every single standardized test. Where PBL shined was in the application of gained knowledge over time. The significance in comparing PBL and traditional classes is to provide the world with enough data and reason to make an educated decision on whether or not to pursue an education that consists of PBL methods or follow the same path so many have ventured down before. The literary search strategy. In an effort to pinpoint material related to PBL, the terms problem-based learning, PBL, high school, and other related searches were entered into the EBSCO library database search tool. This brought up thousands upon thousands of articles, journal entries, web pages, books, and PR articles related to problem-based learning initiatives. For the most part, almost every article was related to Asian schools, medical school, and project-based learning, not the same. To narrow down the search, your year selection, peer review only, and classification of education needed to be selected to close the gap. Once the search is narrowed, some articles began to stand out more so than others. Nearly every article explores the history of PBL before mentioning anything else related to PBL success and failure rates. The literature review. When illness sets in, patients expect the best care from the best trained medical assistants available. A doctor that is more proficient in their respective field of practice, but someone who solves a problem with more than just prior knowledge from a book, but from experience. The same approach should be applied to a child's education. As society changes, so does the youth of the world. The idea that a student should show up, be quiet, sit down, write notes, learn as much as possible for the duration of the educational career, then perform an appendectomy with success is a farce. This is where problem-based learning finds true value. To move forward in educational advances with PBL, one must understand where it all began. PBL was developed as a group-based technique PBL was developed as a group-based teaching technique. It is broken down into 3 different areas of progression: central theoretical learning principles, specific educational models based on PBL principle, and different practices within the guidelines of traditional education models. These are the fundamental concepts of PBL. Howard Bravo, who was involved in the early stage of PBL at McMaster's University in Canada, defines the concept in terms of specific attributes of being student-centered, taking place in small groups with the teacher acting as a facilitator or being organized around a problem. Although PBL is not an exact model during the times of Piaget, Vygotsky, and Lev, there are parts of pedagogical models that value the presence of a teacher in the classroom that utilizes PBL approaches. In 2003, de Graaf and Pacalmos presented theoretical learning principles as follows. PBL is an educational approach whereby the problem is the starting point of the learning process. In the vast majority of cases, students have the opportunity to determine their own problem formulation within the given subject area guidelines. In either cases, the teacher defines the problem and the student uses it as a starting point. Experienced learning is also an explicit part of the participant-directed learning process where the student builds from his or her experience and interest. Activity-based learning requires activities involving research, decision-making, and writing. To prove successful, these theoretical learning principles must also incorporate an interdisciplinary learning relationship with exemplary practice where students have demonstrated objective mastery rather than objective completion. There have been abundant research conducted in favor of PBL practice. As to be expected, there has been many contrasting information that has disagreed with PBL approach to education. Primarily, what is the purpose of a teacher in the classroom if the student is leading the setting, the interventions, resources, etc.? The purpose of this research is to determine the effectiveness of PBL education, specifically STEM pathways. History. PBL did not happen overnight. PBL first began in 1969 in Canada at McMaster's University Medical School. The program included concepts of curricular innovations used in combined field-based programs from the late 1950s at Case Western Reserve Medical School. The program that spent many decades in development and fine-tuning is now being utilized in other fields of study. Some other fields are dentistry, pharmacy, optometry, nursing, law, and business. PBL is no longer focused only within the medical field. As technology and the age of man has progressed, educators have begun to look for more ways to make students become adaptable to the changing world so that they may one day lead it. PBL, the creative process and how it all works. PBL focuses on the development and refinement of the critical thought process. This is extremely beneficial to future educational advancement as well as employment. Colbert says, in courses with PBL, students encounter problems that require critical analysis, in-depth research, and solution development. Educational settings that have adopted PBL are steadily seeing an increase in clear hypothesis development, something that's proven difficult over the years. When paired with poorly structured problem-solving scenarios, developing viable hypotheses and ill-structured problem-solving, this is not a simple process for young problem solvers. With STEM pathways, there is an importance for students to not only know the answer to the question, but rather to ask questions that haven't been answered. The development of hypotheses that continue to investigate the unanswered is what has made PBL so important. If the student of PBL scenarios do not understand this, their educational development will falter. When people generate hypotheses, they tend to stop early, failing to generate a range of possible hypotheses before testing. As a result, they also overestimate the completeness of the hypothesis sets. The creative process is imperative to a successful PBL program. As the teacher sets a scenario for educational atmosphere, it is the student's job to determine whether practice different outcomes and anticipate problems. The creative process can be described as third-age knowledge characterized by dedication and absence of control. To further understand the orders of knowledge as follows. First-order knowledge is factual knowledge, or knowledge can be accumulated as a precursor to reflection on action. Second-order knowledge is reflexive knowledge. It is knowledge about knowledge. On this level, we can choose adequate methods and use our factual knowledge to solve concrete problems. Third-order knowledge takes the form of creativity, where we can see things in a new and intuitive way and not yet embodied knowledge. Fourth-order knowledge, aka world knowledge, represents the social evolution of knowledge. PBL has affected education the same way conceptual change has. In additional education settings, teachers led the students' curriculum based upon school, district, and/or state standards. This built the student's education around that of the teacher. In PBL settings, the teacher knew the answer, but the students led the way with direction and oversight from the teacher. A PBL curricular could be instructed in such a way that students could be obvious to a domain expert, also known as the instructor, but not the students. Conceptual change PBL relied on the activation of prior knowledge, eliciting group discussion and critical analysis of an argument, encouraged deep comprehension of information. Activating prior knowledge. The activation of prior knowledge is the ability to recall information that a student already knew in preparation for a topic to follow. During the pre-discussion of the problem, students come up with the preliminary ideas to explain the problem at hand. These ideas are formed in students' prior knowledge because the pre-discussion of the problem is that scheduled before any preparation of curriculum input, eliciting deep discussion and critical analysis of argument. As students began their discussion, other students became more responsible and recalled even more information. Secondary, because PBL contains group learning, the activation of learners' prior knowledge happens collaboratively and allowed by the group of discussion, encouraging deep comprehension of information. This allows the students to take the information from that day's lesson. Finally, PBL can encourage students to deeply process the information at hand. The successful implementation of PBL program produced a classroom that encourages their approach that was supportive of problem solving. To accomplish this goal, the following steps were used. First, learners are also ill-structured problem that is germane to a specific domain. Second, learners are responsible for their own learning, self-directed learning. Third, learners collaboratively work in the groups to solve the problems. Fourth, instructors act as facilitator. Fifth, learners reflect on the problem situations. The use of structured teams that assist in critical thought process, acquired knowledge, and education advances can be utilized in more than med school. Criticism and validation. The one major criticism of PBL is the fact that there's no definite answer to whether question, was PBL better than traditional methods? Several meta-analysis data suggest PBL has modest and no beneficial effect on student learning or content. What happens to a great deal of difference between performance student standard tests and real-world applications. By comparison, students with traditional methods consistently outperform PBL students. However, in the application of knowledge, PBL students were exceedingly better than traditional counterparts. Students with PBL remember more acquired knowledge compared to their traditional counterparts. The validation for PBL. In the study consisting of 77 students, 64 female, 13 male, a lab was conducted in Newtonian laws where there was 3 groups formed, the PBL, lecture, and self-study. Students were assessed on the ability to adapt to conceptual change and recall information. 3 tests were given, pre-test, immediate post-test, and delayed post-test. 1 week later, due to misconception of Newton's laws, all 3 groups performed very low during the pre-test. However, during the immediate post-test following the experiment, all 3 groups nearly doubled their performance scores. Where the proof of PBL success is demonstrated in delayed post-test. Both the lecture and self-study groups dropped at a full point or more just a week after the experiment. However, the PBL group had very little change. According to Loy et al., 2015, the results demonstrated that students gain knowledge after instruction, either from PBL or lecture or self-study. In addition, a significant interaction effect was found in the study. Bonferroni corrected post-hoc comparison revealed that while no statistically significant difference existed amongst the 3 groups of the PBL pretest, the PBL group with a mean average of 10.63 with standard error of 0.77 outperformed both lecture mean average of 7.78 with standard error of 7.9 and self-study group mean of 8.42 and standard error of 77. Immediately after instruction, for example, the immediate post-test, after 1 week, i.e., the delayed post-test PBL group with a mean of 10.50 with a standard error of 0.78 still outperformed the lecture mean of 6.61 with standard error of 0.80 and self-study mean 7.42, standard error of 0.78 group. No differences are found between the lecture and self-study group, the immediate and delayed post-tests, as you can see by the figure. This one right here is for the PBL. This one right here is for the self-study in the center, and or for the lecture study, and then, or it's for self-study, and then the one at the bottom is the lecture. Having recognized many success stories in PBL implementation of the post-secondary level primary and med school, it's also very easy to notice a small amount of research-related high school education PBL success rates and associated correlations. So for the conducted information for the research was conducted for my classroom, we took for PBL is proven to hold value, higher valuation in education throughout the world of education, no matter the corner of the globe you may live in. Knowing how valuable PBL is institutes in higher education, one may wonder whether or not there's the same amount of value in high school setting. Traditional education has been a staple of education ever since the little red one-room barn-style classroom, regardless if it's public, private, or charter-style class, which is better for high school students' education, traditional educational practices or PBL. Versus research has compared the effectiveness of problem-based educational practices in PBL in a high school and STEM class in an effort to measure independent student performance. A comparison was conducted between traditional PBL students, 24 students, 12 traditional, 12 PBL, ranged between age of 15, 18, and 10th, 12th grade. In engineering and robotics class, given a pre-test, post-test, and delayed post-test over the use and functions of a 30 millihertz dual-trace analog oscilloscope model 2120 Charlie. Information contained in Appendix Alpha to maintain anonymity and determine student group and group associated scores. Traditional students are represented as S001, S002 following. PBL students are as S101, S102, etc. Each group was given the same post-test to measure individual understandings and knowledge as machinery primary to any lesson demonstrating object manipulation. Upon completion of the pre-test, and traditional students were given a worksheet that would use the background of lesson demonstration were conducted in a lab setting by a facilitator. Students were introduced to various problem Control parts of the oscilloscope, various topics were discussed over a 2-week time span for the PBL students. Upon pre-test completion, there was given a user's guide. The same worksheet and traditional students were given in a 2-week window to complete the associated assignment tasks for monitored and verified facilitator lab setting prior to moving forward. PL students were allowed to collaborate with classmates for the last 10 minutes of the class period. Each group was able to complete assignment either before the completion of the 2-week window or on the day of the assignment completion due date. Students from both groups were allowed the weekend to study all the material that they were received and any associated notes. Following week, students from both traditional PBL groups were given the same test they were given 2 weeks prior to determine knowledge retention. They were also delayed 2-week post-test conducted without any prior knowledge given to the test. Data analysis. Research question: will there be a statistically significant difference in academic performance between traditional PBL students, pre-test, post-test, and deleted post-test? It is expected there will be a statistically significant difference in academic performance in favor of PBL practices over traditional educational practices. Check whether two groups are similar based on pre-test. We use the t-test to check the similarities. Null hypothesis was the mean of pre-test scores of both traditional PBL groups are equal. The alternate hypothesis was the mean of pre-test scores of both traditional PBL groups are not equal. Reject criteria. Reject the null hypothesis. The value from the t-test is less than 0.05 due to histograms being inclusive. Kolmogorov-Smirnov test was conducted with sample size less than 30. P-value is greater than 0.05 for both traditional PBL settings. Therefore, we can assume normality. Dependent variable for the pre-test score was measured at ratio level. Homogeneity of variances. P-value of Levene's statistics greater than 0.05. P-value of 1. Therefore, we can assume homogeneity of variances. Visual analysis histogram showed a centered bell skewed distribution since the difference did not appear to be normally distributed. All right, so all that basically comes down to 1. All right, so basically, if you take a look at this, for the histogram, it's just regular bell shape. All right, our statistics. So there's no real difference between your normality and everything's less than 0.05 and all that. All right, it ended up being the same kind of way for our pre-test when we conducted it. All right, we figured out our with the null hypothesis, the mean of the post-test was just like the mean of the pre-test. There would be no that scores of traditional PBL are equal. Mean of post-test score. The alternates that they will not be that they are not equal. We'll reject it if t-test less than 0.05. All right, there was normality expected. All right. However, there is sufficient evidence to suggest that the mean of this post-test of traditional PBL groups was not equal. On average, students scored lower in PBL post-test with a mean average of 90, and traditional post-test with a mean average of 95. Traditional was statistically significant. All right. So, as you see, coming off with your post-test, traditional continued to have the same, but there was still a difference in normality. It was hard to figure out one for the PBL, so we ended up doing another Kolmogorov-Smirnov. All right, the delayed post-test was statistically significant differences in mean. All right, based upon histogram, inconclusive on normality. See the difference in the histograms? All right. Basically, from the hypothesis, we rejected the null hypothesis that there would be a statistically significant difference between the traditional and PBL performance. All right. So, in our conclusion, when initially starting this research, the thought that PBL was outperformed traditional education practice time and time again was the expectation. With such a high volume of success in medical school students and law school, the support was in PBL's corner upon completion of the research method and upon and even in the middle of the conducted test. It was clear very, very early on that numbers would not be as alarming as one would hope for PBL, but rather in traditional education's favor. From the initial post-test results, it was abundantly clear that traditional methods were favorable for student success than PBL's were. A 5-point difference. When initial post-test scores nearly half a grade letter mark higher or lower than another, is not much hope for future delayed post-test results. Something that proved more alarming than the success of traditional methods in comparison to PBL was the apparent loss of acquired knowledge over 2 weeks that was witnessed in the PBL problem. All right, PBL had 80, but we were able to maintain an A average with traditional methods 2 weeks later with the same material coverage. From the research conducted, teachers, administrators, and researchers may begin to reconsider whether or not there is any true value of PBL methods in the high school settings. Being an expectation of research was PBL to outperform traditional methods is a way to support different educational practices to meet perceived societal needs. However, based upon the research conducted, maybe traditional methods are here to stand the test of time. Will this research begin to reconsider PBL practice? Not in the least. By conducting this research, it was clear that the things that we've been instilled in the minds of students and teachers alike from the very beginning of education was missing somehow. The ability to create higher order thinking through process were present, but where they are abundant in the methods that have been proven to work over generation of educations, scaffolding, the interdisciplinary skills, etc., seem to fade away. The ability to perform content mastery of a collegiate level with PBL is within grasp. However, there's something that many high school students are missing. The college level students have mastered before the respective discipline. They have a personal investment. To explain a little further, high school students who are still in the height of their pre-pubescent years or in their pubescent years and development process are more concerned with finding who they are, who's going to be at the big game of the weekend, putting gas in their cars so they can cruise the streets with their friends because they just got their first car. Many students at high school have the typical 45-minute period, 7/8 period long days with focus on studies from the majority of the class period, but not think twice about the class for the next day. When college students and med/law students defer not only the ability to study and have a sense of responsibility outside the classroom, but their understanding of the world around them, the value of what they are studying. The classes and the labs may be long and taxing for students, but an individual understanding the future may hold for them upon successful completion of schooling drives these students, as well as students and student competitiveness. Study more than is required of them. The difference between high school students and college students and how PBL affects their education comes down to timing. High school students do not have enough time to support a PBL-style education. In the future, there may be better suited classroom structures to support PBL and public education systems. Maybe there needs to be an entire restructuring of the classroom type of instruction in the coming years. Consider the state of education for past, present, and future. A sense of satisfaction can be found in knowing that there are methods and principles that have been researched, established, and defined to meet the needs of all students. References and the appendix.